Ever wondered why some neural networks achieve 99% accuracy while others fail to converge? Understanding the mechanics of deep learning isn't just about writing code. It's about mastering the underlying architecture. In this video, we will cover Python deep learning certification practice questions and explanations. Master deep learning with Python with this comprehensive practice exam. This video features 30 real-world practice questions designed to prepare you for official certification. In this comprehensive guide, we are diving into 30 high-yield practice questions designed to mimic the actual Python deep learning certification exam. We will cover everything from gradient descent and backpropagation to advanced CNNs, RNNs, and model optimization. Before we begin, make sure to grab a pen and paper to track your score. Let's see if you're ready to become a deep learning expert. Which activation function is most commonly used in the hidden layers of a deep feed-forward neural network to mitigate the vanishing gradient problem? Option A, sigmoid. Option B, tanh. Option C, ReLU. Option D, softmax. The correct answer is C. The rectified linear unit, ReLU, is the preferred choice for hidden layers because its derivative is 1 for all positive inputs. Unlike sigmoid or tanh, which saturate at 0 or 1, where the gradient becomes nearly 0, ReLU keeps the gradient flowing, which speeds up convergence and significantly reduces the vanishing gradient problem in deep architectures. In the context of atom optimization, what is the primary purpose of the momentum component? Option A, to increase the learning rate over time. Option B, to calculate the second moment of the gradients. Option C, to accelerate the gradient vector in the right direction by dampening oscillations. Option D, to ensure that the weights never reach 0. The correct answer is C. Momentum helps the optimizer navigate the cost function's surface by adding a fraction of the previous update to the current one. This pushes the optimizer through flat regions and reduces oscillations in steep ravines, leading to faster and more stable convergence compared to standard stochastic gradient descent. What happens during a dropout layer during the training phase of a neural network? Option A, weights are set to 0 permanently. Option B, a random fraction of input units are set to 0 at each update. Option C, the learning rate is reduced by half. Option D, the entire layer is removed from the architecture. The correct answer is B. Dropout is a regularization technique where, during each training iteration, a random selection of neurons is ignored or set to 0. This prevents the network from becoming overly reliant on specific neurons. Co-adaptation, forcing the model to learn more robust features and significantly reducing overfitting. For a multi-class classification problem where each sample belongs to exactly one class, which loss function should be used? Option A, binary cross entropy. Option B, mean squared error. Option C, categorical cross entropy. Option D, hinge loss. The correct answer is C. Categorical cross entropy is designed specifically for multi-class classification tasks. It measures the dissimilarity between the predicted probability distribution and the actual distribution. 1. Hot encoded labels. Binary cross entropy is used for two-class problems, and mean squared error is primarily for regression. What is the primary benefit of using a max pooling layer in a CNN? Option A. It increases the number of parameters to learn. Option B. It provides spatial variance. Option C. It reduces the spatial dimensions of the input, reducing computation and controlling overfitting. Option D. It acts as a nonlinear activation function. The correct answer is C. Max pooling reduces the height and width of the input volumes. This downsampling results in fewer parameters and less computational load in subsequent layers. Additionally, it provides a form of translation invariance and helps the model focus on the most important features detected by the filters. Why are LSTMs generally preferred over standard RNNs for long sequences? Option A. They are faster to train. Option B. They use fewer parameters. Option C. They have gates that control the flow of information, mitigating the vanishing gradient problem. Option D. They can only process numerical data. The correct answer is C. Long short-term memory. LSTM networks introduce a cell state and 3 gates: input, forget, and output. These gates allow the network to decide which information to keep and which to discard over long periods, effectively solving the vanishing gradient problem that causes standard RNNs to forget information from the start of long sequences. During backpropagation, the chain rule is used to calculate what? Option A. The forward pass activations. Option B. The partial derivative of the loss function with respect to the weights. Option C. The sum of all inputs into a neuron. Option D. The number of layers in the network. The correct answer is B. Backpropagation is essentially an application of the chain rule from calculus. To update a weight, we need to know how a change in that weight affects the final loss. The chain rule allows us to decompose this complex derivative into a product of simpler derivatives across each layer of the network. If your model has high training accuracy but low validation accuracy, what is likely occurring? Option A. Underfitting. Option B. Overfitting. Option C. High bias. Option D. Vanishing gradient. The correct answer is B. This is the classic definition of overfitting. High variance. The model has essentially memorized the training data, including its noise and outliers, rather than learning general patterns. Consequently, it performs poorly on unseen validation data. Solutions include adding dropout, L2 regularization, or increasing training data. What is the purpose of normalization, min-max scaling, in deep learning? Option A. To make the data follow a normal distribution. Option B. To scale features to a range like 0, 1. To ensure faster convergence during gradient descent. Option C. To remove outliers from the dataset. Option D. To convert categorical data to numerical data. The correct answer is B. Neural networks are sensitive to the scale of input features. If one feature has a range of 0 to 1 and another has 0 to 10,000, the gradients will be uneven, leading to a zigzag path toward the optimum. Scaling all features to a similar small range, like 0 to 1, creates a more spherical loss surface, allowing for faster and more stable training. In a CNN, what does a stride of 2 imply? Option A. The filter is 2x2 in size. Option B. The filter moves 2 pixels at a time when sliding across the input. Option C. There are 2 filters in the layer. Option D. The input is padded with 2 rows of zeros. The correct answer is B. Stride determines the step size of the filter as it scans the input image. A stride of 1 moves the filter 1 pixel at a time. A stride of 2 moves it 2 pixels at a time, which results in an output feature map that is roughly half the spatial size of the input. How does the learning rate decay benefit the training process? Option A. It speeds up the initial training phase. Option B. It allows the model to settle into a local or global minimum by taking smaller steps as it approaches the optimum. Option C. It prevents the weights from exploding. Option D. It increases the complexity of the model. The correct answer is B. Early in training, a large learning rate helps the model cover ground quickly. However, as the model nears the minimum, a large rate might cause it to overshoot and bounce around the valley. Gradually decaying the learning rate allows the model to make finer adjustments, ensuring it converges precisely at the minimum. Which loss function is typically used for binary classification when the output layer uses a sigmoid activation? Option A. Mean absolute error. Option B. Categorical cross-entropy. Option C. Binary cross-entropy. Option D. Sparse categorical cross-entropy. The correct answer is C. Binary cross-entropy, also known as log loss, is the standard for binary tasks. It penalizes the model based on how far the predicted probability, between 0 and 1, is from the actual label, 0 or 1. It works perfectly with the sigmoid activation, which squashes the output to that same 0, 1 range. What is the purpose of padding in a convolutional layer? Option A. To increase the depth of the image. Option B. To ensure the output feature map has the same spatial dimensions as the input. Option C. To filter out noise from the image. Option D. To speed up the convolution operation. The correct answer is B. Without padding, the pixels at the edges of an image are only processed a few times by the filter, and the output dimensions shrink with every layer. Same padding adds zero-valued pixels around the border, allowing the filter to cover the edge pixels more effectively and maintaining the spatial size. Which of the following is a simplified version of LSTM that combines the forget and input gates? Option A. RNN. Option B. GRU, gated recurrent unit. Option C. CNN. Option D. Transformer. The correct answer is B. The GRU is a variation of the LSTM. It simplifies the architecture by merging the forget and input gates into a single update gate, and merges the cell state and hidden state. This makes GRUs computationally more efficient than LSTMs while often providing similar performance. How does L2 regularization, weight decay, prevent overfitting? Option A. By removing random neurons during training. Option B. By adding a penalty term proportional to the square of the magnitude of weights to the loss function. Option C. By limiting the number of layers in the network. Option D. By increasing the learning rate. The correct answer is B. L2 regularization adds the sum of squared weights multiplied by a factor lambda to the loss function. This penalizes large weights, effectively forcing the network to use all inputs a little bit rather than relying heavily on a few. This leads to simpler models that generalize better to new data. What is a tensor in the context of deep learning frameworks like TensorFlow or PyTorch? Option A. A type of activation function. Option B. A multi-dimensional array of numbers. Option C. A specific type of neural network layer. Option D. An optimization algorithm. The correct answer is B. Tensors are the fundamental data structures in deep learning. A 0D tensor is a scalar. 1D is a vector. 2D is a matrix. And 3D or higher are simply called tensors. They represent the data that flows through the computational graph of a neural network. What is batch gradient descent? Option A. Updating weights after every single training example. Option B. Updating weights after calculating the gradient for the entire dataset. Option C. Updating weights using a small random subset of data. Option D. Updating weights only at the end of the training process. The correct answer is B. In batch gradient descent, the gradients are calculated for all samples in the training set before a single weight update is made. While this provides a very stable gradient estimate, it is extremely slow and memory-intensive for large datasets, which is why mini-batch gradient descent is usually preferred. Which metric is most appropriate for evaluating a model on a highly imbalanced dataset, e.g., fraud detection? Option A. Accuracy. Option B. F1 score. Option C. Mean squared error. Option D. R squared. The correct answer is B. Accuracy can be misleading on imbalanced datasets. If 99% of transactions are legitimate, a model that always predicts legitimate will have 99% accuracy but fail to find any fraud. The F1 score, harmonic mean of precision and recall, provides a better balance and is more indicative of performance in such cases. What is the purpose of batch normalization? Option A. To normalize the input data before it enters the network. Option B. To normalize the activations of a layer for each mini-batch, stabilizing and accelerating training. Option C. To ensure the labels are correctly encoded. Option D. To reduce the number of neurons in a hidden layer. The correct answer is B. Batch normalization normalizes the outputs of a previous activation layer by subtracting the batch mean and dividing by the batch standard deviation. This addresses the internal covariate shift problem, allowing for higher learning rates and acting as a slight regularizer. In a generative adversarial network, GAN, what are the two components that compete against each other? Option A. Encoder and decoder. Option B. Generator and discriminator. Option C. Input layer and output layer. Option D. CNN and RNN. The correct answer is B. A GAN consists of a generator that tries to create realistic fake data and a discriminator that tries to distinguish between real data and the generator's fakes. Through this competition, the generator becomes better at producing realistic data, and the discriminator becomes better at detecting fakes. What is the primary advantage of transfer learning? Option A. It allows models to be trained on very small datasets by leveraging pre-trained weights from a large dataset. Option B. It removes the need for an activation function. Option C. It guarantees 100% accuracy. Option D. It only works with text data. The correct answer is A. Transfer learning involves taking a model trained on a massive dataset, like ImageNet, and fine-tuning it for a specific, smaller task. Since the model has already learned basic features, like edges and shapes, it requires much less data and time to achieve high performance on the new task. What does epoch refer to in training a neural network? Option A. One single weight update. Option B. One pass through a single mini-batch. Option C. One complete pass through the entire training dataset. Option D. The total time taken to train a model. The correct answer is C. An epoch represents one full cycle where the learning algorithm has seen every sample in the training dataset exactly once. Training usually requires multiple epochs to allow the weights to converge to an optimal state. In a CNN, what is a kernel or filter? Option A. A small matrix of weights used to extract features from the input image. Option B. The final output of the network. Option C. The activation function applied to the image. Option D. The process of resizing an image. The correct answer is A. A kernel, or filter, is a small window, e.g., 3x3 or 5x5, containing learnable weights. As it slides over the input image, it performs element-wise multiplication and summation, producing a feature map that highlights specific patterns like edges, textures, or shapes. Which loss function is commonly used for regression tasks? Option A. Cross entropy. Option B. Mean squared error. MSE. Option C. Hinge loss. Option D. Kullback-Leibler divergence. The correct answer is B. Mean squared error. MSE calculates the average of the squares of the errors, the difference between the predicted value and the actual value. It is the standard loss function for regression because it heavily penalizes large errors. What is exploding gradient, and how is it typically handled in RNNs? Option A. Gradients becoming too small, solved by increasing learning rate. Option B. Gradients becoming extremely large, solved by gradient clipping. Option C. Weights becoming zero, solved by dropout. Option D. The model training too fast, solved by reducing epochs. The correct answer is B. Exploding gradients occur when large error gradients accumulate, resulting in very large updates to the weights. This makes the model unstable. Gradient clipping is a technique where if the gradient exceeds a certain threshold, it is clipped or scaled down to stay within a reasonable range. What is the purpose of an activation function in a neuron? Option A. To store the weights of the network. Option B. To introduce nonlinearity into the network. Option C. To calculate the error of the model. Option D. To normalize the input data. The correct answer is B. Without activation functions, a neural network would just be a series of linear transformations. no matter how many layers it has. It would only be able to represent linear patterns. Activation functions like ReLU or sigmoid allow the network to learn complex, nonlinear relationships in the data. What is the learning rate in gradient descent? Option A, the speed at which the data is loaded. Option B, a hyperparameter that determines the step size at each iteration while moving toward a minimum. Option C, the number of neurons in the hidden layer. Option D, the time it takes to complete one epoch. The correct answer is B. The learning rate is a crucial hyperparameter. It dictates how much we adjust the weights in response to the calculated gradient. Too high, and the model might overshoot the minimum. Too low, and training will be painfully slow or get stuck in a poor local minimum. In early stopping, what is the criteria for stopping the training? Option A, when the training accuracy reaches 100%. Option B, when the validation loss stops improving and starts to increase. Option C, when the maximum number of epochs is reached. Option D, when the learning rate becomes 0. The correct answer is B. Early stopping is a form of regularization. We monitor the performance on a validation set. Once the performance on the validation set starts to degrade, loss increases. It indicates the model is starting to overfit the training data. So we stop training even if the training loss is still decreasing. What is data augmentation? Option A, deleting unnecessary data from the dataset. Option B, creating new training samples by applying transformations like rotation, flipping, or zooming to existing images. Option C, adding more layers to the neural network. Option D, increasing the precision of the floating point numbers. The correct answer is B. Data augmentation is a powerful technique to increase the size and diversity of a training set without collecting new data. By randomly transforming images, the model learns to recognize objects regardless of their orientation or position, leading to much better generalization. What characterizes a fully connected, dense layer? Option A, each neuron in the layer is connected to only one neuron in the next layer. Option B, each neuron in the layer is connected to every neuron in the previous layer. Option C, it is only used for image processing. Option D, it has no learnable weights. The correct answer is B. In a dense layer, every node in the layer receives input from all nodes in the previous layer. This is the classic neural network layer type. While powerful for learning global patterns, they can become computationally expensive as the number of inputs and neurons grows. That wraps up our 30-question deep dive into Python deep learning. How did you do? If you got more than 25 correct, you're in great shape for the certification. Don't forget to like this video if you found the explanations helpful and subscribe for more technical certification prep. If you have questions about specific concepts like backpropagation or RNNs, drop them in the comments below. For the full-length practice exam and detailed study resources, check out the link in the description below.